1, 2, 3, and this one, students would get to grade 12 and they get something like this and they didn't know what to do because all we taught them is to find those 3 points somehow. But you have instances where the points are given, so you don't even have to come up with them. You just use what you've got. Okay. So here we go. Let's read. Always read and imagine the situation, because that will tell you if it's supposed to be pointing up or down. Sometimes it points up, sometimes it points down. So let's see what happens here. So this is at the back of that handout, at the very back, page 20. And then after we start the new handout that I gave you yesterday. Okay, an airplane performs a stunt at an air show. It consists of a sudden drop, right? A bit of a hint perhaps, followed by a rapid increase in height. So you're dropping and then you increase in height, right? That's what I'm seeing there when I read that. The stunt ends when the plane reaches its initial altitude. From time to time, it's going to be very explicit to tell you when does this end, because a quadratic models indefinitely technically, but we kind of limit it to, it's like just from here to here. The table below shows the heights at different times. And this is another promise that I give you now in grade 12. It's the same thing. If you have a table like this, the first row is always your x variable. The second is your y variable. Like, we're not going to trick you as to you have to pick the right one, right? So we have our x and our y, and we're going to type this into L1, and we're going to type this into L2 and see how it goes. Because A is asking us to determine the equation that models the height of the plane over time, right? So we're going to relate the time and the height with the equation. So let's go ahead and do that. And you can tell that the numbers are big or bigger. And another thing I want to tell you, that I don't know if you noticed, time does not start at 0 here. So we don't know what the initial height is. So we'll figure that out. Okay, so stat, right? You press stat, edit, clear, enter, right? And then just type it in 2, 6, 8, 15. Look at that that jump, right? 2, 6, 8, then all of a sudden 15. That's okay, right? Just go with it. And I'm just gonna check. Yep. And then 750, 315, 210, and then 433.13. And you should have matching tables. Like if this one is shorter than that one, it's going to complain, right? So you have to have matching. They have to match up perfectly. All right. So let's perform the regression now. We go back to stat, calc, 5, second 1, comma, second 2, comma. I want to show you a shortcut here actually. So let me clear. I'm going to clear what I just did here. You just performed a quadratic regression, right? If there's nothing in between, you can hit second, enter, and it actually calls that the same function back. And everything is there already that you did before. So you don't need to do all of those keys again, right? It's already there. The only caution the only thing that I will mention here is that don't forget how to do this, because you will do other calculations and then you can't do the second enter, right? It's not going to save you every time, but it does save some time. And then you hit enter, and that's the equation that I get. So I'm actually going to perhaps use this space here to help me out. So I'm going to go stat, calc, 5, and I will state the equation. Y is equal to, and it's 9.375 x squared minus 183.750, right, x plus 1080 and that's 0.00. I'm just going to leave it at that. I like that round number at the end. So that is the equation that models my scenario. Just double check. Is that what you're getting? Did some of you do that? Yeah, you're getting that? Okay. I just don't want to be off by mistakenly typing the wrong number. So we've got that one. We've got the equation. Now we work with that. What's the initial height of the plane at the start of the stunt? Right? So B at time 0, right? So that's the y-intercept. You're essentially asking you to state the y-intercept, right? Or to go find it. That's going to help you. It's a bit blurry. Let me just try here. At time 0. So the y-intercept is 0, 1080, right? So initial height is 1080, and we are in feet, right? So in this case, you do have units. So that one was not too bad, right? You could just read it right off of your equation and boom, you're done, right? So you're done B. How long did the stunt last? And that's where you have to read, okay? It tells you that, right, it ends, watch up top here, stunt ends when the plane reaches its initial altitude. So when it gets back to the 1080. So let's find a window where we can see this thing. Let's just hit graph. Let's see what happens if we just hit graph. Will that work for us? And it did not work for me. So I'm going to use zoom 9. However, I did not turn on plot 1 yet. If plot 1 is not turned on, zoom 9 does not work. Okay, it will do nothing for you. So plot 1 has to be turned on. Then you can hit zoom 9. Zoom followed by 9, and see how the points show up. Like, it creates a window to make sure all the points you've entered are visible. It's not always ideal, however. So I, for example, would like to see the x-axis. That's just what I would do. So I'm going to go ahead and change my window. I'm going to go lower and out a little bit. Lower, out, and also higher because I want to know my y-intercept. So let's go to the window. X-min, watch this. I'm going to change it to -5 or -10 because I want to see a little bit in the negatives just so I can see everything. My X max, I want to see a little bit more to the right, so I'm going to increase that to, let's say, 30. My Y min, I'm going to go -5 as well. I think that will do it. And my Y max, I want to see, where's my Y intercept? 1080, correct? So I'm going to go 1200 or something like that. 1100 would do, right? So I've basically started with zoom 9 and then change everything to make it work for me. I'm kind of thinking, right, let's just expand my window in all directions and then hit graph. And that's a much better visual now, okay? So we started here, the stunt starts right here. And the stunt is performed, and it says that the stunt ends when it gets back to where you started. So I don't know about you, but I'm thinking, let's make y2 equal to 1080. Why am I doing that? Well, it tells me on both sides of the parabola where that height is, right? So it's there and it is there. This is where the action ends, okay? So let's on C, we go y2 is 1080. I'm going to go second, trace 5. right? Because I want to know that intersection. I'm going to find that intersection. I know that this is 0, 1080. I want to find this one. So second trace 5. Let's go. I'm already close, but I'm going to go a little bit closer just because I'm used to it. Enter, enter, enter. And you get 19 point. That would definitely round to 60, right? 1080. Right? So you go from 0 times 0 to 1960 when you're back to that, right? So how about this? I want you to have a bit of a visual. So this is just a sketch. Time, height, and we have something like this, right? So this point is right there. Just make the dot a little bit bigger there. This is the height of 1080, right? So this is our initial height here, 0, 1080, right? And then the stunt happens, drops, goes back up, and this is where it ends, right? So that's where I get that point from. So the stunt, right? It takes 1000, no, not 1000, 1960, right? 19.6 seconds. Okay. Obviously, on a test or whatever, I don't need you to do all of that. This is just for you, right? These are your notes. And I would like you to have detailed notes, as detailed as possible, right? So you understand how I got it. Does that make sense? Yeah? All right. If it doesn't, I have 25 cents for you. D, graph the scenario. No, no, no. Sorry, I'm off here. What's the lowest height? So we need to find the vertex, because that is where, right? That's the lowest point in this case. So we're gonna go second, trace, min. By the way, I never asked you. I hope you realize that it makes sense that this parabola points up, because it's a plane, drops and goes back up. It does make sense that it points up. I picked this example so you're not always used to it pointing down. So my A value was positive, right? So everything is jiving. You're thinking, you're like, yep, 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 everything is making sense. Let's find the vertex, second trace, min. So I have to press 3. And my cursor is way up there. So I have to go to the left of the vertex. So I got to keep going to the left till I pass it, hit enter, then back to the right, hit enter, and then enter. And there it is. 9.80, 179.63. That's the vertex. So this is the lowest point right here, right? Lowest height. You can just do it like that, is 179.63, and we are in feet. So watch for that. It could be yards, meters. My worksheets, that's another reason I don't like the textbook. It's always meters. It's always meters. It shouldn't be, right? You should have different units, so you're always paying attention to that. E is graph, right? Can you like try to ace a graph, folks? Like it's actually very doable. Okay, so let's go ahead and do that. What's the first thing you should be doing? Label, right? Time, in this case it's seconds. This could be distance, right? It could be money. You will see down the road. So it's not always time. And then up here, arrowhead, and its height. And so I put these grids in so it's a little bit easier to graph, okay? So you need to at least add those arrowheads on the X and Y axis, stay in the quadrant, in this quadrant 1. And so what is a good scale? I'm looking at normally, listen carefully, normally it's your x-intercept. In this case, what are we going to focus on? When does the action stop, right? It stops after 19.6 seconds. So 5, 10, 15, 20, that'll do. Right? That is a good scale. You could go up by 4s if you wanted to. And then here, I need to go all the way to 1080. I need to make sure that fits. So let's see. 250, 500, 750, 1000. So I'm going to go up by, how about 200? 2, 4, 6, 8. Yeah, I'm going to go up by 200. Well labeled, well laid out. And I'm going to do this here. So this would be 1100 right here, right? Between 1000 and 1200. So I'm just under it there. Okay. And 1960 is very close to 20. So I'm going to kind of just go up and try to match the initial height. That is right across from it. So that's my, when the stunt ends, and then my vertex is 9.8, 9.8, which is very close to 10, and 170 is right about there. So I'm making sure I'm not touching the 200 line and I'm not touching the 10 line, right? Then I understand that you understand what's happening. And so now you just have to just go down, but not straight to the vertex, and then curve. And then you go back up. Beautiful, right? So no air, there should be no arrowhead past this, past the end of the stunt, because it stops, right? And last but not least, include your equation. So I'm thinking, 4 or 5 minutes to do a good graph. Usually by the time you get to the graph, you know a lot about the curve. But if you don't, find the vertex, find your intercepts. Notice that this one has no x-intercepts whatsoever. So you kind of have to just go by the y-intercept, the vertex, and this point here, right? And these should be, you should understand that from here to the center is the same as from here to the outside. All right, we're not done yet. Domain and range. Let's skip that one. No, we can't. We can't. We have to learn how to do it. So F, I'm going to do that right here. For my domain, that is my X variable. So I'm going to go from 0 all the way to where action ends, which is 19.6. I'm going to state it in the other format. Squiggly brackets, 0. And this is a bit controversial, right? Because I tell you to use the letters that you've used. And we have used X for our time, right? So we're going to stick with it. And 19.6 squiggly brackets there. For my range, I go from the lowest height that I reach. I'm looking here, 179.63 all the way to the highest point, which is 1080. And in the other format, we remember smallest first, largest second. If you remember that, you're gonna, what did I do? See, this is not right. Okay, you can't use square brackets when you're doing set notation. They're very picky with that, so you have to use the, I don't have a name for them. I call them squiggly brackets. That's the best I've got. Okay. And G, last but not least, how long was the plane at or above 800 feet? And this is where you need to think, okay? I'm going to make y2 equal to that height that I'm interested in. And I'm going to go second, trace 5. I will provide you with just a quick sketch here. Right, this is time, this is height. We know that, right? This is happening. And the 800, this is 1080, so the 800 line will be somewhere here. Right, this is the 800 mark. So this is where my highlighter is going to come in. And this is where you need to think. It's actually interested in this, right? At or above 800. It's interested in those little stretches, right, where the plane was above the 800 line. It's not interested in this. It's not interested in the time that went by below 800. So this is the easiest way that I know how to do it. I will find these two times. So just like before, I will find that. So time 1 and time 2. We're going to figure that out. So let's go ahead and do that. I'm going to zoom into that. In the meantime, so let's go ahead and find that. Y2 is 800, so clear that. And let me just bring this up here. Graph. So at second trace 5. I will find the first one, which is to the left. That's close enough. Enter, enter, enter. 1.6653. Remember 4 decimals when you do these? 1.6653. And let's find the other one. Second trace 5. Jump over to the horizontal and just go right across. And that's 17.9346. Yeah, I like how I hear a lot of clicking as well, like you're trying it out, right, live. Now, if we subtract these two, we're going to find the time it stayed below, right? Because this is the time this time. If you subtract them, you're going to find the time below. So I'm going to say this. Time below 800 feet. I'm going to go delta time. And I'm going to go 1793 dot 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 minus 1.66 dot dot dot. So I'm going to actually perform that calculation. 17.9346 minus 1.6653. So 16.2693 seconds. This is the time it spent below 800 feet. time above, how would I find that? I take the whole time, the whole stunt. So I'm going to go 19.60 minus 16.2693. I'm going to take away the time the plane spent below from the total stunt, right? And then, and now you're scratching your heads like, I need to get out of here, right? So the time is 3.33 seconds. And I'm going to highlight this orange so you know that this time right here is your time spent above 800, because we figured out how much. Let me try to find a different way. When you subtract, you find the time spent on that hill or the dip. If you're interested on the rest, you need to subtract that from the total. Yikes, this is a little bit crowded here, but I would like to do like this is the stunt, right? I think it's going to be too busy if I do that. And so let me just conclude with this. It says there, homework is page 11 to 12, right? Oh yeah, that's perfect. 11 and 12, this is your homework here. 2 questions. 1 point's down, 1 point's up. I think. I have to double check. I already posted the answer key before you came to class. Please try these, okay? It might take you half an hour, 40 minutes. And